The last other type of equation we're going to be looking at are absolute value equations. Um, and I feel you will absolutely value them as an important part of this class. Waka, waka, waka. Um, trying to give you guys the full in-class experience with bad jokes, bad puns, just lots of sort of cringy humor. So there you go. An absolute value, of course, right? Those are the two bars. They look kind of like brackets. They, in some sense, act a little bit like brackets, but more importantly than just a sort of grouping property, they give you the positive version of whatever is inside of them, right? So an absolute value of 3 is 3, an absolute value of negative 3 is also 3, right? You're sort of erasing any negative values. How do we deal with this if we see it as part of an equation? So there's sort of a good news. Well, I wouldn't even say good news, bad news. There's just rolling pieces of good news. So part of this is we're not going to see any equations that are super complicated. It will mostly just be linear type math, linear sort of looking equations with the absolute value in the mix. The idea is you want to isolate the absolute value part of your equation. So shift everything away from it. So just get the absolute value is equal to some number. And then what will happen is you will split your equation into two cases, into a positive and a negative case. And from there, you just solve it. It's going to just be nice sort of linear steps, a la what we were doing back in section 1.2. So let's start with an example. Say, for instance, you have the absolute value of x minus 2 equals 7. This is about as straightforward as an example as we're going to see, right? Just absolute value equals number. We don't need to rearrange or do anything here. So what this means is x minus 2 could be 7. It could also equal negative 7, right? And then when I applied the absolute value, I would sort of flip that negative to a positive. So what I'm going to do is essentially just set up two simultaneous equations, or you can just sort of do them one at a time. I kind of just mirrored the steps here and have them sort of both written out. So x minus 2 is 7, or x minus 2 is negative 7. We sort of have these side by side. The nice thing here is the steps to solve it will match, right? We're just going to add 2 to both sides to sort of get to our final answer, and that's going to get us a positive 9 or a negative 5. If you kind of do a quick mental check with either of those values, right? 9 minus 2 is 7. Absolute value of 7 is 7. Negative 5 minus 2 is negative 7. But then with the absolute attached to it, it comes back to positive 7. So a pretty quick solution. We're able to sort of get to our answers without too much fuss. It's just based on this one sort of principal move of writing this as two separate equations, a positive and a negative version. If we did something a little bit longer with a few more pieces, it still is the same basic strategy. 2 times the absolute of 3x minus 2 plus 4 equals 20, right? So what you want to do is shift your terms around so that you can isolate the absolute value. So subtract the 4 off of here, right, would give you 16. Right, 2 times the absolute value is 16. How are you going to get rid of the 2? Well, it's 2 times, so you're going to do a division by 2, right? So then this would really mean that the absolute value of 3x minus 2 is 8. From there, we can break ourselves into the two cases. So this would be a positive 8 case and a negative 8 case. 3x minus 2 is 8. 3x minus 2 is minus 8. And then from there, we have these sort of simultaneous solutions. Again, you don't necessarily have to do this. I'm not suggesting you have whatever, some sort of wild ambidextrous, one pen in your left hand, one pen in your right hand, and you're solving them both at the same time. That would be pretty impressive. That would be a pretty cool trick. That's not what I did. I just did them one at a time. And then I just sort of wrote them side by side. So however you want to write this is fine. Just make sure that you have both of these cases, right? So you're adding 2 to both sides. That's going to mean 3x is sort of 10 on the left. If we add 2 on the right, 3x is minus 6. The last thing, of course, to get x by itself would be a division by 3. So we're going to get, one of these is a fraction, right? So a positive 10/3, just leave it as 10/3. The other one would be, right, -6/3, which would be -2. And in theory, again, right, either of these numbers will sort of work back in the original. If we do just a quick kind of mental math, right, -2 times 3 is -6, minus 2 is -8, absolute value is 8, 8 times 2 is 16, 16 plus 4 is 20. If I did 10/3 as mental math, 10/3 times 3 is 10. 10 minus 2 is 8. Absolute of 8 is 8. 2 times 8 is 16, plus 4 is 20. So both of those check out. They are totally legit. Your expectation for the absolute value problems is that you are likely to get two different numbers, not necessarily, right, a positive and a negative of the same number, but you'll get two totally different numbers, right? In this second example, we had sort of a positive fraction and a negative whole number. In this example up here, we had a positive whole number and a negative whole number. You could just as easily get two positive numbers or two negative numbers. You could have a case where both of these actually end up at the same value. It might be that the value is 0 if that's the case. In any event, lots of different possibilities here. So don't expect that you're necessarily supposed to get one type of answer over anything else here. Any number will do, any number or any fraction. And there you go. That's the end of 1.6 as a recap. Please feel free to watch these videos early and often. Pause them. I'm probably talking a little bit faster than I would if I was actually writing everything out. So definitely pause them, rewind them. The downside, of course, is you have to listen to my voice, but you can probably turn on some sort of closed captioning and just read instead. So however you guys want to do it, these will be up. We'll go from there.